मेरे प्यारे बच्चों, टुडे हम डिस्कस करेंगे चार्जिंग ऑफ कैपेसिटर आरसी सर्किट. रेजिस्टेंस R and capacitor. I am connected this capacitor C, capacitance C. I am connected with the battery having voltage B. This is positive terminal, this is negative. This battery voltage B. Charging RC circuit. RC circuit. RC circuit. Now, this is the capacitor having capacitance C. This is the resistor or load having resistance R connected to the battery. When at t equal to 0, this is a switch. T equal to 0, I am just going to close the switch. Then current start flowing in this circuit. At any particular time t, we assume t equal to 0, I am going to close this circuit. At any time t, suppose this capacitor having charge Q, this in plus Q charge, and this is minus Q charge. Now, if I am taking this terminal voltage, this side voltage I am taking 0, then this side voltage become B, because difference maintain B. Able to choose any voltage. I am able to choose here 0, then this point become B, and this point also become B. And this is 0 means this point potential also become 0, because this is connecting wire. Then this point potential become what? Q by C, because we know Q is equal to C into B. Then B become what? Q by C. Now this is the charge on capacitor at t equal to, at any time t. Charge on capacitor at time t. T equal to 0, capacitor completely discharged. No charge. Then suppose I am writing the equation of current passing to the resistor. I is equal to what? Potential drop how much? B. This point potential is B, this point is Q by C. Then B by Q by C upon R. This is the current passing through the resistor at time t. At particular time t, current passing through the resistor, resistor is this only. Now, and this is what? Instantaneous current means at any particular time t means instantaneous current. Instantaneous current we can write I is equal to dq by dt. This is the instantaneous current. Instantaneous current at any particular time t. Then this is the equation of current I already got. Now I am going to substitute the current I am going to write dq by dt. Now this equation number second. From first and second we can write dq by dt is equal to b minus q by c upon r. Now I'm just going to solve this. dq by dt cb minus q by r c. Now I'm going to use variable separable method to solve this integration. dq upon cb minus q, I am going to separate the variable, and dt by rc. Now at t equal to 0, charge on capacitor 0. When t become at any time t, charge on capacitor is q. Now I'm going to integrate this. Integration, integration of dx ax plus b is equal to nothing but 1 by a ln ax plus b. This is the basic integration of formula. We can going to be able to use this formula in this solve. Now, sorry for that. If I'm going to integrate this part, then I'm writing here minus 1 by 1 because the coefficient of q is minus 1. ln cb minus q limit 0 to q is equal to rc, 1 upon rc, 1 upon rc, and dt we can write here t, limit goes 0 to t only. Now this minus term I'm going to multiply here, then able to get ln cb minus q is equal to minus 1 by rc minus 1 by rc t only, and this unit 1 0 to q, and this also goes 0 to t. Now this part I am going to write ln cb minus q minus ln cb is equal to minus 1 upon rc into t. Now I am going to write this ln cb minus q upon cb log a minus b, nothing but log a by b, minus 1 upon rc into t. Then I am going to solve this, then able to get ln, now now cb minus q upon cb exponential e power t upon rc, t upon rc. Now try to solve this, then able to get q is equal to cb, cross multiply this and able to shift this, 1 minus e power minus t by rc. This is the equation of charge at any time t, means this q charge is function of time function of time. Means accumulation of charge accumulation when time will increases, accumulation of charge at the plate of capacitor will increase. Now I am going to check also when I will cross check this when t equal to 0. This is the equation of the charge at any time t. At any time t. I am putting t equal to 0 in equation third. Then charge become what? CB 1 minus e power minus 0 by RC. Then able to get 0 only. Then this also satisfy the things when time is 0, then charge on capacitor is 0. Because initially capacitor is discharged. Then t equal to 0, charge on capacitor is 0. Charge on capacitor is 0. Is 0. Now, when t going to infinite, when time tend to infinite means time tend to infinite, this known as steady state condition. Steady state condition. When I am going to put t equal to infinite in equation third, then q become cb 1 minus e की power infinite. Infinite upon RC, nothing but infinite only. Then able to get q maximum, able to get how much? CB only. Then for finding the maximum charge, able to get time become infinite. At t equal to infinite, the charge is maximum on the capacitor. Now again, I am going to discuss one other things. We already know current equation is what? I B minus Q by C upon R. This is the current equation of current at any time t. This is the equation of electric current passing through the circuit, electric current at any particular time t, Now when t equal to 0, then q is 0. Q equal to 0. I am going to put in this equation number 4. This is equation number 4 I am using. T equal to 0 and Q equal to 0. T equal to 0 means Q 0. Then the current become what? B minus 0 by C upon R. Then current able to get what? V by R. Then current passes to maximum when time is 0. At t equal to 0, current passing, current is maximum only. Current is maximum. Now, then at t equal to 0, what we can write? Note point one note point right now. At t equal to 0, capacitor will at t equal to 0, capacitor replace with connecting wire. Yeah, replace with wire, because this circuit become what? Now circuit become like this only. When t equal to 0, circuit become like this. I am going to replace capacitor with wire. This is the wire, connecting wire. Okay. And this is the voltage V plus minus this resistance R. Then current how much able to get in this? Current able to get how much? I is equal to V by R at t equal to 0. Now next, this is a note point, note down. Note is this. The next point is what? At t equal to infinite, at t equal to infinite, when t become infinite, then current how much I want to get? I is equal to V Q by C. This is the current equation at any time t upon R. When t tend to 0, then Q become what? CB. When t become infinite, then Q become like this. When t become this, then Q become like this. Put the Q value in this equation number this. When put the value of Q in this, then able to get I V minus CB upon C upon R. Then CC cancel out, B minus B by R. Then current become 0. Current become 0. Then t equal to infinite, then at t equal to infinite, capacitor act as a open circuit. Capacitor act as a open circuit. Means we can replace the capacitor, we can remove the capacitor. Means capacitor we can remove. Then the circuit become like this. This is the battery. Now like this. This point I am remove capacitor. I am going to remove the capacitor. Now this circuit become what? Open circuit. Open circuit means current is 0. No current will go. Then t equal to infinite, capacitor behave like open circuit. Then one thing I will explain here. In RC circuit, I already explained all things about this. The expression of the charge, this is the simple basic circuit diagram I will take here. This is the capacitor, resistor and switches here, and this connected with the battery. T equal to 0, I am going to close the switch, then the current start flowing in the circuit. At any time t, I wrote here the current equation this, and then this is the at any time t current equation. This means I we can write dq by dt, that is instantaneous current. Then I am going to replace this like this. I am going to this only. This is the I am going to substitute the I value here. The equation able to get this. I am now using this integration formula is this. And similar this also same to the like this. Then able to solve this and applying the limit here. Then able to get these things. Okay. Then again rearrange these things, and if this ln go this side, then able to become exponential of this. Then able to solve this, and this equation is very very important. That the charge equation at time t. Now charge is the function of time t. T equal to 0. When t equal to 0, this important is if charge on capacitor becomes 0, you can check with this also. Initially capacitor is discharged. T equal to infinite means that stage known as steady state condition, the charge become maximum in the capacitor, is charged completely. At T equal to 0, now I am going to check at T equal to 0, what is the Q0? Then I am going to place in the instantaneous current, Q value able to place here, then able to get current is maximum, T equal to 0. Current is maximum in the circuit means capacitor is no upper resistance means capacitor will replace with the connecting wire. Then circuit diagram like this. This capacitor I am going to connect with connecting wire. I am using this and connect these things. Then the current become like this. At T equal to infinite, my dear student, Q becomes CB. Now I am going to substitute the value of Q in this equation. Then I want to get the current is 0. If current 0 means definitely the circuit become open. That's why capacitor I am going to remove, and this circuit become open means current become 0. No current will flow. And this is all about the charging of the charging of capacitor or RC circuit. And next session will explain the current, how the current will vary with the time, and we'll try to plot some graph. Now today is in